Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 3, 3.1, and we'll be looking at the graphs of exponential functions. But first of all, what is an exponential function? Well, an exponential function is any function of the form y equals a to the power of x, where a is a constant and x is the variable. So something like 2 to the power of x, or 5 to the power of x, or 10 to the power of x. Anything like that is called an exponential function. Now, we'll be considering two possibilities for the value of a, because depending on the value of a, you can get two different types of graph. The first case is where a is bigger than 1, any number bigger than 1. We'll think from first principles what the graph's going to look like. So first of all, we'll think about the crossing points on the axes. To find the crossing point on the y-axis, we say what happens if x is 0. Well, if x is 0, we'll have a to the power of 0. Doesn't matter what a to the power of 0 is always equal to 1. So if x is 0, y will equal 1, and that means there'll be a crossing point at 1 on the y-axis. What about crossing points on the x-axis? To find those, we'd say what happens if y is 0. Now, if y is 0, you'll have 0 equals a to the x. It doesn't matter what a is, it doesn't matter what x is. A to the x never equals 0. The consequence of that is that there will be no crossing points on the x-axis. Now we'll think about what happens if x gets bigger and bigger as we head towards the right-hand side of the graph. The technical way of saying that is what happens as x tends towards plus infinity. Well, as x tends towards plus infinity, we'll have a number bigger than 1 to the power of a number which is getting bigger and bigger. So as x gets bigger, y is also going to get bigger. As x tends towards plus infinity, y also will tend towards plus infinity. They're both going to get bigger. The way we show that on the graph is just by drawing a little line here. And that shows as we head towards the right and x gets larger and larger, so does y. What about looking on the left-hand side, which is as x tends towards minus infinity, becoming more and more negative? This is a little bit more confusing. It means we'll have a to the power of minus infinity. The minus means do 1 divided by. So we'll have 1 divided by a very large number. 1 divided by a very large number gets smaller and smaller as the number gets larger. So as x tends towards minus infinity, y is going to get smaller and smaller. It's going to tend towards 0, which is down here on the left-hand side, getting closer and closer to 0. Now, that is all you need to know to sketch the graph of y equals a to the x. If we join these together, then we'll get something that looks a bit like that. And it doesn't matter what a is, as long as it's a number bigger than 1, that is what the graph will look like. It will cross through 1 on the y-axis, regardless of what value a has. It'll get bigger and bigger to the right, smaller and smaller to the left. Okay, let's do an example of just thinking about how different values for a do give you different looking graphs. So you're asked to sketch these 3 graphs on the same set of axes. You don't need to do accurate scales or anything like that. You've just got to get the general shape right and show how the graph changes if we do change this number. Now, just to give you a little bit of help, the bigger the number you have, the faster things happen. So if you have a bigger number, 5 to the x, it's going to get bigger quicker. And on the left-hand side, it will get smaller quicker. Everything happens faster. Okay, I'll let you have a go at seeing if you can make sense of what all of this means. So 3 sketches, you just have to do them very quickly on the same set of axes. So pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So y equals 3 to the x. Well, it doesn't matter what the number is, they all have the same general shape. Y equals a to the x always goes through 1, always gets bigger, and then always gets smaller as you tend towards minus infinity. So y equals 3 to the x would look something like that. Y equals 5 to the x will have the same general shape, but it'll get bigger quicker because you've got a bigger number here. And because we're doing 1 divided by it, it'll also get smaller quicker as we head towards minus infinity. So y equals 5 to the x will look something like that, where it gets bigger quicker, but notice it does also get smaller quicker on the other side of the origin. Y equals 2 to the x, well, that's the smallest of the 3 numbers, so everything will happen more slowly. It'll get bigger more slowly. It'll also get smaller more slowly. So on this side, it won't be so steep, and on this side, you'll notice it's on the top, it's getting smaller more slowly than the other 2 curves. Okay, that was case 1. Now case 2 is considering values of a which are bigger than 0, but less than 1. So any value bigger than 0, but less than 1. It's a little bit more confusing in this case, but we'll go through all the steps again. What will the curve look like? First of all, if x equals 0, well, you'll have a to the power of 0. That hasn't changed. Doesn't matter what a is. A to the power of 0 does equal 1. So if x is 0, then y equals 1, or f of x equals 1. Doesn't matter what a is. So the curve is still going to go through 1 on the y-axis. What happens as x gets bigger and bigger? Well, you've got a number which is less than 1, so it's like a half or a quarter or a third. If I do a bigger and bigger power of that, it makes the fraction get smaller and smaller and smaller. So as x tends towards plus infinity, y is going to tend towards 0, which means that the curve's going to head towards here on the right-hand side. What about as x tends towards minus infinity? Well, that's the most confusing case of all. As x tends towards minus infinity, you'll have a fraction to a negative power. The negative means you'll turn the fraction upside down and you'll have a number bigger than 1. And because you've got a number bigger than 1, when you take a power of it, it's going to get bigger and bigger. So as x tends towards the left and towards minus infinity, y will tend towards plus infinity. So it's going to head over here. It's a reflection of the last graph in the y-axis, and you'll get something that looks like that, as long as a is between 0 and 1. Okay, once again, we'll consider 3 possibilities just to show how they compare to each other. So again, don't do accurate scales or axes. You're just doing a sketch of these, and you're doing all 3 on the same pair of axes. So have a go at drawing all 3 sketches and showing how they compare to each other. Now, the difference this time is that the smaller the number, so 1/5 is the smallest, the faster things will happen. And the bigger the number, a half is the biggest of those numbers, that's the slowest things will happen. Okay, bearing that in mind, have a go at this yourself. Pause the video, come back to me when you're ready. Okay, let's have a look. So y equals a third to the power of x. A third is between 0 and 1, so the curve will be that way round and will look something like that. That's all you need to show. It goes through 1 on the y-axis, it's bigger on this side, heads towards 0 on that side. If I change the number to a half, now that's a bigger number, but the consequence of that is that things actually happen more slowly. So if I draw a half to the power of x, it'll head towards 0 more slowly, and it'll get bigger more slowly, and it'll look something like that. If I have a fifth, 1/5 is the smallest of the fractions. The consequence of that is things actually happen quicker. So a fifth to the power of x will get steeper more quickly, and it will head towards 0 more quickly on this side. So everything's the opposite way round from when a was bigger than 1, which is a little bit confusing. Okay, example 3. On the same axes, sketch the graphs of, first of all, y equals a third to the power of x. Well, we just did that, so just do exactly the same as what we did on the last question. And then sketch y equals a third to the power of x minus 2, indicating where that curve crosses the y-axis. So again, it's not accurate scales or axes, we're just doing a sketch. So sketch, first of all, a third to the power of x, and then the real question is, what does this mean? If I change x to x minus 2, how does that change the graph and what it looks like? Okay, I'll let you have a go at seeing if you can remember some work that you've done on transformations in the past, and if you're able to work your way through this yourself. So pause the video, have a go, and then come back to me as soon as you're ready. Okay, let's have a look. So a third to the power of x, that's exactly what we had in the last question. Now what we're really asking is, how does that change if I change the x to x minus 2? Well, if I change the x to x minus 2, what I've really got here is I've changed f of x to f of x minus 2. And if you remember the work that we had on transformations earlier on in P1, what that will give us is a translation of f of x in the opposite direction, so 2 to the right. A translation of f of x by the vector 2, 0. What that means is that the whole curve is going to shift to the right by 2 units. What will that look like? Well, something like that. So the green curve has just moved to the right by 2 units. And the other thing we've been asked to find is the coordinates of this point here. So where does the curve now intersect the y-axis? So that's the point we're looking for. Same method as we used earlier on. If we want to know where it cuts the y-axis, we just say, well, what happens if x equals 0? So we'll substitute x equals 0 into the equation, and that'll tell us where it cuts the y-axis. So putting in x equals 0 here, I'll just have a third to the power of minus 2. The minus turns the fraction upside down. So 1 over 3 becomes 3 over 1. So a third to the power of minus 2 is exactly the same as 3 squared. 3 squared is 9. That means this crossing point here is at 9 on the y-axis. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 51, and in exercise 3A, you only need to worry about questions 3 to 6. Have a go at those. Thank you very much for listening, and cheerio.